Have you ever really looked at a tiny pill and just wondered, how? How did they figure all this out? Well, today, we're going to pull back the curtain on the incredible science that goes into calculating the perfect dose of medicine and then follow it on its amazing journey through your body.
You know, it really is a Goldilocks problem, isn't it? If the dose is too little, well, nothing happens. But if it's too much, it could be harmful. So how in the world do scientists and doctors find that just right amount? It all starts with a very specific field of science.
So our journey begins with that first huge question: how much? And trust me, this is no guesswork. It's a dedicated science.
And that science is called posology. It literally means the science of how much. It's the entire field dedicated to figuring out the exact right quantity of a drug. But here's the really interesting part. The right dose is almost never a single fixed number. Why? Because we're all different, which means the dose has to be personalized.
Okay, so if one size doesn't fit all, what are the big variables that scientists have to juggle? Let's take a look.
And wow, the list is actually longer than you might think. Some are pretty obvious, right? Like age and body weight. But it also includes how you take the drug. A pill is way different from an IV drip, and even something called accumulation, which is just how a drug might build up in your system over time. Every single one of these factors plays a critical role.
Let's just zoom in on age for a second, because this is one of the most important factors. Our ability to handle medications changes dramatically as we go through life.
And you can really see why at the two ends of the spectrum. An infant's liver and kidneys are, still learning the ropes. They're not fully developed yet, so they can't break down and clear out drugs as well. And on the other end, elderly patients can be much more sensitive to side effects, so doses often need to be tweaked to avoid problems like confusion.
And then there's body weight. This one just makes sense, right? A larger person is probably going to need a different dose than a smaller person. So, to keep things consistent, doses are usually calculated in milligrams of drug per kilogram of body weight. It's a way to standardize the dose relative to your size.
So, we know the factors, but how do you actually put them all together in the real world? Let's look at how a dose is calculated, especially for kids, where getting it right is absolutely crucial.
One of the classic ways to do this is with something called Clark's rule. It's a pretty elegant formula, actually. You start with the child's weight in kilograms. Then you divide that by 70, which is just a benchmark for an average adult weight. That gives you a fraction. You just multiply that fraction by the standard adult dose, and boom, you have a pediatric dose that's tailored right to the child's size.
Okay, so the correct dose is calculated, it's been taken, but that's really just the starting line. What the body does with that drug is just as important as the amount you take in the first place. So now we get to follow the drug on its epic 4-step journey through the body.
And the science of this journey has a fancy name, pharmacokinetics. But don't let the word scare you. All it means is the study of what the body does to a drug. It's like tracking a package from the moment it arrives to the moment it leaves.
And this image right here gives us the perfect roadmap for that journey. The whole process is known by a handy acronym, ADME, which stands for the 4 key stages every single drug goes through.
So let's walk through it. First up, you have A for absorption. That's just getting the drug into your system. Then D for distribution, which is how it spreads out to where it needs to go. M is for metabolism, which is where your body, usually your liver, starts to break the drug down. And finally, E for excretion, how your body gets rid of it.
But for any of this to happen, the drug has to get past a major obstacle. I mean, a huge one. It needs to find a way to get inside our cells. So let's take a look at that cellular border.
This is it, the biological membrane. Think of it as the bouncer or the gatekeeper for every single cell in your body. It's this fatty layer that is super picky about what it lets in and what it keeps out. For any drug to do its job, it has to figure out a way across this barrier. So how does it do it? Well, there are 2 main ways. The first is called passive transport. Think of this like floating down a river. The drug just moves naturally from an area where there's a lot of it to an area where there's less. No energy needed. But then you have active transport. This is like firing up a motorboat to go upstream. It takes energy for the cell to literally pull the drug inside against the current.
So when you really step back and think about it, we've seen the whole story. It starts with a super precise calculation to figure out the dose, and then it kicks off this incredibly complex journey through the body. It's an amazing process from start to finish.
After seeing all of this, from the math to the biology, what's the single most important idea to walk away with? It's simply this.
That dose you're given isn't just some random number. It's a personalized map for that drug's journey, designed just for you and your body. That pill isn't just a substance. It's more like a message with a specific address, sent on a very predictable, well-understood path to make sure it works safely and effectively.